And good evening and welcome to this evening's webinar, Coding Basics with the TI-84 Plus family, hosted by Texas Instruments Australia. My name is Rodney Anderson and I'll be your host for this evening's webinar. And here we go. One of the panelists tonight is a very experienced gentleman, John Bament. Are you there, John?
Good evening. Yeah, good evening all. Thanks, Rodders.
No worries. And the first panelist to start tonight is Brian Lannen. You just see there, wow, 30 years, Brian. How do you feel?
I'm getting a little bit tired, but no, look, yeah, I keep looking at new technology and it excites me and I get back into it.
That's fantastic. So, Brian, you'll be the host soon, or the ball will be passed to you, so I'd like you to start this evening's webinar.
And a photo of John, and a photo of me, and a slideshow from here.
Yeah.
Interesting. Yeah, interesting topic. This coding. First of all, we'll overview what we're looking at this evening. I'm going to talk briefly about the current curriculum focus, or shall we call it a craze, on coding at the moment. And then John's going to talk about, then I'm going to talk about 10 minutes of code, which is a resource that's on the TI website. Very, very easy to get into to start off. And then John will talk about what is actually happening, what's real in his classroom, and if we get time, back to me for, whoops, as things are advancing on me, back to me to talk about a new product that's soon to come out from TI called TI-nspire, which is a real-world interface where we can use coding to drive things, flashing lights and motors, and listen to the environment and take measurements and all that sort of good fun stuff. Now, on this coding across the curriculum initiative, it's all the rage at the moment. I have here a reference to a media release from the Federal Minister for an investment of over $3.5 million for resources that support the teaching of coding in schools. And I used this, I was actually in Canberra just a couple of weeks ago at their conference, and by the way, if anyone has the opportunity to get to the Canberra Maths Association conference, I highly recommend it. It's a good one. They have some great speakers and some great presentations. And can I also put in a quick plug for their hosting of the AAMT conference, which will be next year. I think it's June or July. It'll be our mid-year holidays. It'll be cold. It'll be cold in Canberra, but it's going to be a great conference, so I'll put in a plug for that one. So there I was in Canberra, 20th of August, as you can see, hiding in code, because their theme was hiding the mathematics. That's their symbol there. I thought, as I've used before, code, you know the start of the matrix thing with the little dribbling down of the green code, and of course we're not really living in any sort of reality, we're just parts of a computer program. So I used that just as a little warm-up, and then I thought, can I do it myself? Oh, that's me. Whenever I introduce the topic of matrices to my students, I hit them with this silliness. They hate it. Oh, Mr. Lannen, do you have to? But really, coding is cool, and to prove it, I found something when I was in search of that little video clip. I found this on YouTube. YouTube's lovely, isn't it? And I learned how to do this code myself. Watch this. How sweet is that? Now that is cool. You've got no idea how long it took me to code all that in to make my computer screen look just like the Matrix. Oh, look, it took me, well, not very long at all. In fact, it's this simple. That is the actual code. That's the code that creates that green screen of repeating numbers. And I learnt it from, I think it sounded like a 12-year-old boy who had made his own YouTube clips and posted it up there. That's the reference there. It was that simple. And of course everyone's jumping on board. The ABC are having a go. They've got to show, well, I've I enjoyed the first series of the code, and I think the second one is due to start this week. So everyone's jumping on board with this coding thing. Back in Canberra, here is the words from the Minister, and this business of, the coding across the curriculum initiative will increase student engagement and support with high-quality teaching in technologies. So, whether or not you see value in the actual coding, in my day it was called programming anyway, but it is a big initiative, and there's money attached to it. And if you're like me with teaching, you look at what the initiatives are, and you look at the catchphrases, and you attach it to any funding submission you might be submitting, and see what you can get coming your way. I might like you to just reflect now on your own coding experience. I appreciate we will have participants here of different ages and different background experiences. As Rodney so graciously pointed out, I've been doing this business for about a little over 30 years now. I was super excited the first time I got access to this thing called a computer, which was a terminal in a room next to the actual computer. I was very fortunate because I actually had a terminal that I could type into, and I had a video screen that I could see my programs execute on. If I'd started that college 1 year earlier, then I would have had to use punch cards. So that was my first experience. What was yours? Can you remember? If you're teaching this with your students, it's probably worth sharing these sorts of stories. And was your first use of a computer, were you playing with coding? I was. That was my very first encounter with a computer. Fortran was the language then. Have you subsequently taught computer or computing studies? Have you taught coding, maybe Game Maker or Logo or some of the other languages and applications? How did you go with that? Are you still doing it? What resources would you use and recommend? Are you a leader on this in your school? Because what we hope to show you in this webinar this evening is that even if you have absolutely zero experience with coding, there are some very, very accessible resources on the Texas Instruments website. This is the front page of Texas Instruments Australia and New Zealand. You see, you've probably already found the bit that describes webinars, and you're making use of that, obviously. And there are some other wonderful parts of this website for activities, downloads, lesson plans and so forth. But this one here, TI Codes, is a relatively new one. 10 minutes of code. I don't know where they got the name 10 minutes from, because there's actually hours and hours worth of work in there if you want to do it. But maybe the idea is that if you only invest 10 minutes, you will be coding. You will be getting value from that. So it supports 2 platforms. So if you're using TI-nspire, there's a whole set of lessons on that. And John and I are in fact running this webinar for TI-nspire tomorrow evening, same time. But this evening's webinar is on the 84 Plus, and the way the website is set up is that we get the coding, so this is online step-by-step lessons. We get a teacher's lounge, which allows you to download the whole lot, and a little bit of extension here. So the course is set up with 5 units. Within each unit there are 3 short lessons that they call skill builders, and then there's 1 application. So if you've learnt the ideas from the 3 skill builders, the application is the challenge to then put those ideas into creating something. What you won't find is complete programs, complete strings of code. They're set up, and I'll show you shortly, they're set up to teach you the ideas of coding, where how you put a display statement out, how you accept input of information, how you need to format things, rather than just mindlessly copying down strings of code and pressing a button and say, oh, that's exciting. In the Teacher's Lounge, there's sets of files, both for students and teachers, and also links to a more detailed e-books if you want to take it further. So you can download the whole thing, and you can see I've hyperlinked here. You can download the whole thing, and here it is, TI codes, resources, and I've got the Unit 1 skill builder for the student, and then there's the teacher version. Unit 2 skill builder for the student, and then the teacher version, and so on, and the application. So you'll see I've got the 5 units of activities here. To give you an idea, skill builder 1 for the student, it's all in a single PDF zip file. So you could either have students working on the website where they get this information drip-fed to them by step 1, step 2, step 3, or if they're not going to have computer access in class time or for homework or however you're assigning the work, there's a 2-page document. You can print that off and give it to them. And with this document, it's very self-explanatory. This document and their calculators, they will be coding within 10 minutes. And John will verify that when he tells you about his classroom experience. Accompanying that student PDF is another document. This one's 1 page longer, where you get some tips and comments and some of the answers, but not all, for the teacher. Notice in the screen captures here, you're not getting the entire amount of code. There's some bits of it and screen captures that illustrate what it looks like when it executes, but you don't get the whole thing there. So they're designed to make you think and work through them. If your students are particularly good and they've gone through the 5 units, then the Beyond Basics assigns 3 additional applications, which are, I thought, rather advanced. So basically, choose your own adventure. That's the idea there. But that's all showing you on a PowerPoint. Let's see what the thing really looks like. That's what we want to see. So I'm going to take you now to my web browser and show you on that. And I'm also going to show you at the same time on a calculator. I'll just take this back a page or two just to show you again how I got here. So here's the web page, Texas Instruments, Australia, New Zealand. Here's our 10 minutes of code. So we hit that. Choose your calculator. We'll go with the 84 CE. And choose 10 minutes of code. Start here. It's probably a good place to start. And here we have the 5 units. So in the first unit we get just the basics of programming, how you can display stuff on a screen. The second one, we introduce the use of variables. And the third one, condition statements, if, then, and so on. Let's just have a go at the first one. So I'll open this up. And you see, as promised, 3 skill builders and 1 application. So a quick introduction here. You can flick to the teacher's notes if you wish, or let's just get into it. Step 1. Within 10 minutes you will be coding. Turn on your calculator. Well, I'll turn it off in order that I can turn it on. Hang on, it's not going to... I'll get out of that. So, I'm on the emulator. So I've got my calculator turned on, and it says hit program. So you see here under my program key, whoops, I was on second there. I shall quit out of that. Under program, you see a string of programs in my calculator that I've already written, because I've already been playing around with this. So that's why there's a whole list there. If I then move across to new, so I tab twice to the right, and I'm going to create new program. So you see this screen is similar to what's in the notes. Press enter, and I need a name for my program. it says in my instructions over here, I call it Hello XY. Now, guess what? I've already got a program called Hello XY. I'm just going to call this one Hello. So back over here, and we'll go with HELLO. Now, program name cannot contain any spaces or special symbols. Just go with letters. When you start typing it, the cursor will already be in alpha lock mode, so you would actually hit the green alpha keys, or you see read the green to type the alpha. I've just used my keyboard, which speeds things up quite a lot. So the program Hello is now being written, and the cursor has jumped down to the next line. It is no longer in alpha mode. What is interesting is that if I go back and press this program key, I get a different menu. This is because we're now in the process of writing a program. So I need to go to step 3 to see what I'm to do next. And so it's telling me that I've got the new menu, and step 4 will tell me I want to select DISP, which is short for display. So I can arrow once across to IO, standing for input output. So the first thing this program does when it executes is it's going to display something, DISP. I can either arrow down and press enter, or I could have just typed number 3 because it's the third option there. So that's the first thing on the first line of execution of my program. What's it going to display? It's going to display in inverted commas, "You are so cool." So notice that my cursor is not an alpha cursor. I can either press the alpha key and hit U. I need first of all the talking marks. I've made a mistake here, so it's very simple. I just arrow back and type over that. But notice my cursor is not in alpha mode at the moment, so I'll go alpha, talking marks. Now I'm going to make a mistake here deliberately. If I then press what I believe to be the U key, oops, I've got number 5. That's because the cursor had dropped out of alpha mode. It's going to be better, and you can see in the notes here, my life will be easier if I lock it into alpha mode by pressing second alpha. So second alpha, and it's now in alpha lock. So I'm going to type U, space. Now space is on the 0. See the little symbol here? So U symbol, and then R, and underscore, and I'm going to use my keyboard because it speeds things up for me. So, cool. And unfortunately the quotation marks won't come from my keyboard. I've got to go back here to do that. And enter. And let's go to the next step. And it says my program is complete. I've done it already. I'm feeling really good about this. It's congratulating me as well. So to run it, I now need to get out of the programming end of things. So I do that by going second and mode key, which is quit. So now I'm back to my normal home screen. If I press program, you see that the third on the list here, hello, it has been added. It wasn't there before. I had hello XY and hello YZ, which is from my earlier preparations. But if I go to program number 3, that's now pasted onto the home screen, our PRGM hello. So it's ready to be executed. I just have to press enter, and it executes. It's worked, and I am so cool. And this thing says I am too. It's congratulated me.
Well done, Brian.
Well done.
Well, 10 minutes too, Brian. You're a good programmer.
It's worth noting at that point, Brian,
Right,
that we don't need to do any save, that the calculator automatically just saves it as we're going along. There's no need to do any of that when you quit. And the only slight downside is there's also no undo button. So
Yes.
that's why you can just quit it and then just run it as you wanted.
That can be a problem, yep, as you say, particularly if I want to investigate some program code. For example, I'll hit program. I've got one here. You see CMA2. I prepared that for the Canberra Maths Association. So if I come across to edit and then press enter, I open up that program code. But if I accidentally type something different in here, then that's automatically part of that program. So unless I saw what I did, like for example I might just do this, and what have I done? Have I destroyed it? In fact I have. Can I remember what I had there? I had the term DISP, but I've forgotten. So if I quit now and try to run that program, program number 1, program CMA2, you see it's broken. I've wrecked it accidentally. So that can be a problem. So be aware of that when if you're in edit mode reading program
There's
lines.
no major problem, because all you do is just create a copy and work on the copy and leave the original as it is. So there's ways around it. I was thinking more with the saving, that it's just automatically saves as you're going along.
Yeah, I do really like the idea. I was actually writing a lot of these, John, on the flight to Canberra, and as the thing was bumping around and rocking around, I got kicked off the screen I was on, and so then when I opened up my calculator again and went back in, everything was saved. So I was really happy for that. So it was saved, and I could just continue my working. Now, John, I can show the next skill builder, or I can go straight to the application. Do we want another skill builder?
No, I reckon go to the application. Looking at the time, I reckon go to the application, Brian. That'd be good.
Straight to the application. So after learning a few things here, in the application, it then said, let's create a program called Border. And I thought, oh no, this is just going to be so hard. It's not telling me the answers. It's asking me to reflect on what I've learnt in the 3 skill builders and create this program. You can see it's given me the first couple of lines. If I've worked through the skill builders, I would know what clear home does. It actually clears the space. I'll just quickly show you here. If I run the program hello, you can see there it is, but it's now fitting, on this screen of mess. It would be nicer if it cleared the screen and all I saw was the hello. So I'm actually going to edit that program. So I'm going to edit program number 3, hello, and I'm going to insert, I'm going to put second and then INS, insert. So my cursor has changed to a different type. It's now an insert cursor. I've pressed enter and put another line in. I'm going to go back to that blank line and put in the command clear screen, which is in the IO list under number 9. And I found that basically not having done much coding on TI at all, within the space of a 1-hour flight, I had these things up and running, and I was learning where these things were. I was very quickly finding them. So there it is, and as John pointed out, the thing's already compiled, it's saved, it's there. So if I just simply quit from here, and now try running my program hello, I was waiting for that to clear the screen. Did it not? What have I done? Program hello.
Go and have a look in your program.
Maybe I didn't. Yeah, maybe I didn't save it. Oops, hang on. Quit out of that. So hit that. Oops. I think I needed to put enter once more. That's what it was.
Clear table, not clear home.
Clear table, we looked at that
Oh,
clear
clear table. That's what I've done.
If you look at your table, so if you look at your show them now, Brian's clear the table, where a table is stored.
But these things for the students are quite nice when they're creating a program, Brian, and it's not working as they planned. it's quite clear for them to
you
follow
go
that
back
through
in.
and to go, where is it making my mistake? And I think that a lot of times we don't have opportunities for them to reflect on what they've done, like either the answers are in the back of the book or somebody else helps them and tells them the answer. So with coding, they got to go, okay, where is my mistake? They've got to read back through it, almost proofread their work. So there's lots that can be learned from that sort of thing, even if they make errors.
Yep. So there it is. I've changed that, and I did find you're absolutely spot on. I did find that as I was doing more of this, that I was learning from those mistakes, which is real. That's real learning. And so now you see it's now worked as I'd hoped. So the application, just quickly coming back to that, asked me to create something like this. So I've got this border around the page and then some text positioned in the middle of it. And I thought, wow, how am I going to work that out? So I messed around. First of all, I took a while to figure out where I'm getting these asterisks from. Do you know where the asterisks are, John?
The asterisks, well, I suppose I would get them from catalogue myself, as I don't know the quick place to find them, but they could be in vars as well, I expect.
Rodney, do you know?
Is it the multiplication symbol on the 84?
It actually is, yeah. And I knew that. And then when I sort of stumbled back across it, I thought, of course I knew that. It's the multiplication sign. So I'll just quickly show you that program. I called it Title because it creates a title page if I had more of a program. So here it is here. So it's program 0. So I'll run it. And there it is. I thought I had to type that in because I felt so clever by doing it. And I'll just share with you the coding. Also there's something clever here. It's stalled the program, so rather than stop and say, hey, done, it's got something happening. I'll just quickly show you here. I'll make this a little bigger and show you. There's a little, hey, I'm busy symbol happening up in the top right here. So that means that the program is still running, and it will continue to run and therefore continue to display this page until such time as I press enter, and now it's done. So now the program is finished. Some of the little tricks that you learn along the way. I'll just show you the code by going into edit. It was number 0, and this was it. So I cleared home, I displayed all of this, and as you can see I've sort of set this up to count that it goes exactly across the screen. Then I displayed one of them, and the last one, so that's the first and last. These are all spaces. I had to put all those spaces in. And
Can you remember, sorry to interrupt, Brian, you remember how many characters across the screen?
Oh, I did count. Is it about 20? Whatever it is you see in front of you, I've forgotten, but that is actually what I did. It was very, very analytical and very much a puzzle-solving process. And I did feel quite clever by being able to do it.
Very clever.
Now, I know that there'd be shorter ways to do this. Of course, I could repeat the line, I could do a loop and so forth. But at this basic stage, at this very basic, this is outputting to the 10th line, first column. And I've got this in quotation marks. Yeah. So my message is, it's very easy to make a start on. It's very simple what I've just done there. There's nothing too, there's nothing too wonderful about it, I know, but very, very simple to get your students started on it. And if they feel the same as I did, they'll feel quite rewarded by learning from mistakes and then modifying things and solving the puzzle until they get to what they're wanting. So, John, how was your classroom experiences with all this? I'm going to stop sharing my...
Look forward to sharing that. Thank you, Brian. Like you said, it is so easy to use the website and to follow it, whether you've done coding before or not. So hopefully more people get on board and see how easy it is to use. Okay, so just pass over to me, and you should be seeing my screen any minute. Rodney, I'll let you let me know if that's the case.
Right at the moment, and it's just about there. That was a good introduction from Brian, what he went through, and looking through the 84 and where to start, and look at the website and teach yourself and self-paced learning. And as you saw there tonight, it's very, very quick to start your first program and do some editing. So we'll still not see your screen. Oh, there's your screen now, John. You're ready to go.
Lovely. Thank you very much. So, yeah, good evening all. I've been doing programming or coding, for want of a better word, on the TI-84 calculators for many years. And I think it is, as Brian showed you, fantastic that we now have the 10 minutes of code on the website for teachers to access. But it also, I'd like to show you the programming or coding that I've been using, perhaps a slightly different approach where potentially you could intertwine it, coding into your regular teaching. So this would be like a sort of separate things, or maybe 10 minutes at the start or the end of a lesson. I perhaps would show you something that before this was available for me that I would do. And one of the topics where I would first introduce the fact that the TI calculator can make code is with quadratics. I can think of it, last year I was doing it with my year 10s, and that would be in terms of solving the quadratics using the quadratic equation formula. I quite like introducing it here, as students have done plenty of heavy algebra, they've rearranged equations, and they've used substitution, and I want them to have a break from that, but really understand what the values they need in the quadratic equation formula and the sequences or steps that's involved. So I would download the, or I have already on my computer, the TI-84 guidebook, and in that guidebook there's a section on programming, here, chapter 16, and there's a big chapter there which I wouldn't give to the whole students. It is available on afterwards on this webinar as an attachment if you'd like to have a look at it, but the section that I would give them is these 2 pages, the program control section, and explain what some of the language is on there, and equally the second page I'd give them is the input or output, which is what Brian started talking about as well earlier. So I'd give them that as a document and say, okay, look, this will make us code, and then I would just run one. So here's probably a simple one that I'd run with them to start with. I'd run this one because they would know the answers before we had to do it. What is the length of the rectangle? So I'd get them to choose a number. What is the width of the rectangle? And I know it's got nothing to do with quadratics at the moment, but it gives them an idea of what can be achieved, the width, and then it comes up with the answers. And they know, we've discussed that they already know that the answer would be 15 for the area, and the perimeter would be 16. But say, well, that's pretty cool that I can get the calculator to do this for me. So again, then I would show them the program, and here it is in edit, and so here we go. A bit like Brian's, here's the display. I've put this as 2 separate lines because else it runs off of the screen and comes back round. It's much easier to have it as 2 separate lines. I'm prompting them, so I'm wanting a variable, and then I'm displaying a second line or 2 lines. Again, I'm prompting them for the width, and then the calculator behind the scenes is actually doing its own calculation, and it's storing it, which as teachers we should be using that store button with calculators with variables generally, but we can now use it in the program. There's a store button there, and it then also does it for area, and it does it for perimeter. It then displays a bit more of a sentence and then spits out the answer they had for A, and also will spit out the answer they had for P. So I'll show them that because really that's all they need to do their own quadratic equation formula, and then I would let them just have free reign. The nice thing is when they've created one, I want them to share it with the class. So I would then use TI Connect. Oops, my calculator's turned off. There we go. I would find that program in their document, so I'd connect it using a USB. I would save it in my file here, which then would allow me to put it onto my computer and show it on the data projector or whatever resources I would have to use it from there. So I would show this one and then show one of the students. So here's one of the students that my students created. All right. And the nice thing is that we could talk about, okay, what is going on? What is the program? Can you, just from looking at this, can you think about what the students have done to do this? So obviously this is a display here. This is another display and a third line of display. this is a prompt. So we've got that one. Another value for a prompt. Let's go 5. And let's go 6. That looks okay. That works out mathematically. And there we go. So again, it's quite nice to talk to the students about what's going on behind the scenes and see how others did it and whether it's similar. But then see if we can break those programs and see actually what happens if we do other things. So you'll see that if I run that program again, just by simply pressing edit again, let's go for one that doesn't have any zeros. And we can see that it now crashes and it doesn't like that. So this, what Brian said at the start about a simple program, that to me would be a simple program, but it obviously doesn't like the fact that it gets no zeros or no real roots. And I think this screen is regularly overlooked by students. They regularly just, because I think the dark section's on the 1, on the quit, they just quit. They don't think that perhaps they should go to it, so either scroll down or just press number 2 for go to. And here's my program. So here again is what Brian talked about, the clear home. There's the 3 lines, so yep, it is what I thought. And here's the prompts, A, B, and C. And we can see that here's that first line. Now, again, a nice little teaching tool to say this is, well, why is it not working here? What's actually happening? Well, obviously, we know that it can't square root a negative, and this here is the discriminant, and it gives a negative value. So some really nice reflection by the student.
Yeah, detective work and problem solving.
Looks like John has just lost connection with his phone there, Brian. Are you still there, Brian?
Yeah, I'm still here. I was just about to say I didn't know whether it's my phone or his. So, John, we've lost you.
So how about, Brian, if we, have you got your 84 open at the moment?
I have. I can show a similar program. If you swing back to me.
I'm just trying to do that right now as we're speaking, or the Texas entrance may do. Yeah, I think you're about to, you can share your screen now while John comes back online. So can you share your screen now, Brian?
Yep, and that should be on its way. Okay, so again, looking at quadratic equations, and it was in fact one of the ones that was in the later applications and the skill builders, and I got there. I've worked through a bit of this. I've been doing my homework. And you see down here, first of all, there was one called Pythag, and then there's another one, Quad. So it's a matter of sort of setting up different loops and things and getting it to do different things along the way. This one works through the formula. And I can use the solver. So that was just a display thing. So I don't know, A equals, let's go with, I don't know, we'll do a standard 1, 1, and 1, and what will we go with? Negative 6, see what happens. And there we get the 2 roots. So that's an interesting one. And
Wait, as you were doing that, Brian, when you're saying you're on a flight from Melbourne to Canberra, I was very impressed you didn't watch the movies. You were just working with the calculator. How motivated are you?
Look, highly motivated, and people may have sort of inferred from that also, perhaps just sort of cutting my preparation to the last minute. But but I got there, and it worked. Yeah. I'll reveal the code. The quad one there is it's got a fair bit in it. I'll just reveal that just so you can have a bit of a look at it. So using labels, output. When we get a command output, see it says an output must first of all start with a bracket, an opening bracket. So output bracket, and then it's got 2, 1, and the next thing is quotation marks. So what this will do is it's specifying exactly where the output is going to go. So this is saying second line, first column, and it's going to output quite literally these dotted lines. And then the next thing, in the third line, first column, it will output a whole heap of spaces and then 2A. And then it'll pause and so on. And so it's clearing. So there's a fair bit in here. There's parts of, there's your discriminant, and it will give in this one, and if we get the discriminant, what's going to happen here, b squared minus 4ac is less than or equal to -1, or 2a equals 0. So it's going to finish that loop, so to speak, and then advance to no answer. I'll just show you one of the other ones that was actually from the program, from the 10 minutes of code program.
So Brian, what you're doing there, you just continue on there. I think John may have lost internet connection, so you keep going what you're doing there.
Altogether. Jindabyne.
Trying to get back online.
She's a bit stormy where I am at the moment. That's Yak and Dander, so things could be interesting in Jindabyne. We're getting a few storms here. So this was the application task, and again, I'm very proud to have written this from not being. And this is the whole point, is, guys, if someone as simple as me can write these things, fathoming through the step-by-step guidance from that the 10 minutes of code website, if I can do it, then I reckon maybe you and your students will be able to do it. It was fairly straightforward following those step-by-step guidance. So, as you can see, this is a Pythagorean triangle calculator. Let's go for the really obvious. Yeah, a equals 3 and b equals 4, and you know the deal. And so this is using that output to a specific point. So that's so many lines down and 2 columns in, hypotenuse is, and that will have closed off the quotation marks there, and it's output the value. This 5, of course, will change depending on the values that I put in. And as you can see, it's now stalled, so that's a lovely looking clear screen until I press enter, and it's exited from the program. So I'll just quickly show you the code. So if I go across to edit my Pythag here, so what's happened? First thing, I cleared the home. I then displayed this program computes, and then on to the next line, the hypotenuse. Because what happens if I put too much in the one line, it just messes up, like it breaks, and like it doesn't word wrap. So I've just put those into 2 different lines, and I found that once again by trial and error. Enter the legs, and what's happening, so that's what the user will see, will come out, enter the legs, ... and then it says prompt AB. So it will that's where you saw A with a question mark, and then B with a question mark. And as the user responded to those question marks, like you saw, I typed in 3 and then I typed in 4, those values have then been taken into the program, and A has taken on the value 3 and B has taken on the value 4. It's then cleared the home. So it's taken in the information it needs. First of all, it put out the information to the user, saying this is what I want you to do. The user then followed what he was asked of, and then the program took in the 2 values. At that point, we can clear the home, because the purpose of all that was just for the program to work out values for A and B. And now the program's clever enough to work it. It's got all the information it needs to do its calculation. So it outputs to the 5th line, 2nd column, the term hypotenuse is. And what I've done is I've put a space after is. There's a space right here. And then I've put my closing quotation marks, just so that the 5 doesn't appear immediately after the S. So it's just a space, otherwise it would look a bit messy. Again, trial and error. And it's now going to output to the point 516. I worked out, so it's on the same line as this text, 16 spaces in, so I've counted all that up so that, so that I know where it's going to go. A square root of a squared plus b squared, you know the deal, and then it pauses, so that pause is what makes the program stop and not close down, not take away all information and just say, hey, I'm done. So that's the text. I'll just quickly show you again the execution. So program, pythag, it's cleared the screen. It just put out those 3 display statements, and it's put up the first of the prompts. Let's go a little different here. Let's go, I don't know, 6, and I press enter, and then it says give me another one. Okay, let's go with 8, and I press enter, and the hypotenuse this time is 10. Okay. Oh, and yes, we can also, in case you want, and you see it's stuck in the program here. It's got the prompt there, or the pause there. It can, in fact, do decimals as well, rather than the exact integer values I've done.
So, Brian, while you're doing that, personally, I love using the 84, marking assignments when students have, for example, using their Heron's rule, and they've collected some data and did some measurements. Instead of me typing it in, I actually write a program and then type the numbers in for their measurements, and it calculates the error for me, the semi-perimeter. I use it a great deal, programs to check student results. So there's another thing as teachers what we can use. The students are programming, but as teachers we can save time when doing all that tedious marking.
Yeah, that's great. And really the students can set this up, particularly, see this calculator is non-algebraic, supposedly. It's everything numerical. It's not a CAS calculator. So students can actually type in all their formulas, their area and volume formulas and whatever, semi-perimeter, you name it, and they can have them stored in programs. So in the exam, they just call up whatever program they want, and excuse me, I think that actually is doing algebra, because the algebra was in there. You saw it programmed into the code. I know this isn't my main classroom calculator at the moment. I use Inspire, but I've spent over that 30 years many of those, in fact more than not, with using the various TI-82, 83, 84, 84 plus, 84 plus CE generation of calculators. Students were smart enough, once they got onto this, they were writing programs, they were swapping programs with each other, they were finding them on the internet, various student blogs and forums. I know one of their favourites was Factor, where they could factor polynomials. So rather than mess around if they've got to find the roots, say, of a cubic or even a quartic, they could do that. Polynomial division was another one that was a favourite.
Brian, can you hear me?
I can now,
John.
yes.
Hello,
Yeah.
good evening. Well, that was all exciting, wasn't it?
Very exciting.
I'm sure that people did that just so they could listen to you more, Brian, rather than me. I think that's what it must have been.
Yeah. Just before I swing back, John, can I just show the last thing that I think is going to be, this is going to be an absolute revolution. And I know it's available in the United States now, and I'm waiting for it to come here. TI Innovator. What you've got here is this little black box and the breadboard on the outside. So you've got your various connections. You can put in various probes in here, say temperature probes and light meters, all sorts of goodies. If you've used the CBL before, a lot of that will interface with this. And you can run programs from either of the calculators, whether it's the TI-84 or the Inspire. Again, with the massive focus these days on STEM, this is, and tied in with coding, this is going to be a huge thing, I believe. I'm just waiting to sort of get to play with these a bit more. Yes, so John, did you want to tell us a little bit more of your story?
I would, I would if you don't mind. If you don't mind, keep putting the internet on me, Brian. If you don't mind, if that's okay with you.
Oh, you want me to drive the internet?
No, I'm fine. Yeah, back over to me would be great.
Oh, okay.
I'll finish this off.
How are we going there, John? The ball moving past to you. You might be able to show your screen.
Is that okay?
Still grey screen there for the moment. Still registering your screen.
There we go. Should be able to see mine now.
I can't see it at the moment, John, so maybe it's just still coming through. It'll come through shortly, hopefully. Can you see it, Brian, on the screen?
No, I can't. I'm just thinking the other option is if I can drive a calculator and John can do the talking.
Oh, here we go. There we go.
You're there, mate. Yep.
Okay.
You're there.
So we're back in quadratics. Yep.
Really was slow internet, eh? Must be all that chilly weather down here that just not going to keep up with it. All right, so back to this, and we'll just finish off as quickly as I can with this. I'm sorry that I got cut off earlier. So, yeah, this, as you can see, then they're trying to square the discriminant, which isn't going to work. And again, great discussions with the students over that. So you'd get the students to go away and think about how they can change that program. Like I said, you don't need to save it. It automatically saves itself. So then and I will just show you the program, so rather than actually run it through this time, and we'll go to number 6. We can see that the start's the same, the display's the same, the prompt is the same, but then we add these extra lines in. So what you can do, as Brian showed you, is do the insert functionality and add a few extra lines. So here we now come up with the discriminant, and we've now got a decision happening. So this program is now making a decision if that, and all these are found, all these actions are found in the program, either in the control section or in the input-output. Most of the other things over here we can also play with and have extra things going on, but most of the stuff that we'll need is in the input and output and the control, hence the 2 documents I showed you earlier that I would hand to my students for them to have a play. And so if I just choose that one for now, because I need to just press enter on that, you can see now that I've now got that there. That before was the display, so I'll go back to that and change it to program across to display. And there we go, we haven't messed that program up. Then it will display this, else, so it's an if or else, it will then, do something else, and it will then display that. There's only one route, and it will give us that route. So again, really nice. If one of my students produced this, there's some really nice teaching that when we could show this, again, like I explained, transferring it with TI Connect to show it on the big screen and get students to discuss it. So as Brian said, we had... Of the formula. Yeah. Say again?
I was just saying, a lot of real understanding of the formula.
Very much so, yeah. And I would also find that even just from showing them that basic area and perimeter formula, they would fly with this sort of stuff, and then they would want to know more, which I could then direct them to the guidebook. But the nice thing now, with that Teachers Lounge on the internet, on the TI Australia website, the students can then actually do much more filters, and they can actually follow it themselves. So they want to know more about the program for the input outputs. They can learn much more. So, there's a prompt. They can learn much more, a filter much easier to find out what's going on. And yeah, I was really finding, Brian, that students were using it on other topics that I was teaching later in the year. And I just think it's not really a cheat, really, because, they've got apps on here that, there's PolySim that does exactly the same as the quadratic equation formula. And that's just a program in itself.
Yeah.
But the depth that they gain from it, and the deeper understanding is really powerful, to have to create the program. And then also on top of that, not only having they created it, if there was exams and that, then the calculators get cleared anyway. So there's no major drama. Now the next one that Brian talked about, and I've got about 5 minutes, so I'd like to talk about, is the loops. And for that, I'm just going to bring up a question that was in a few years ago, was in the Australian Mathematics Competition for Middle Primary, and this is a lovely visual, I think, for a loop to explain what's going on and what we could get the program to do. On the Arab code, Mark Zuckerberg talks about how if he wants to send a message out to say happy birthday to so many people, how do you do it? Well, it's obviously will be something like this. So these are a nice loop. And I'll show this to, so that even though this is middle primary, which is years 3 and 4, I would still give this to my senior students to say, well, okay, can you create me a program for that? So I'll show you that one. This would be a basic form of the program that they would create for me. So let me just go to that question again. So we start with the number 5, we subtract 2, we multiply that answer by 3. Is that answer greater than 50? If no, not, we come back round again. And if it is, what is the answer? There's obviously a multiple choice for these year 3, 4 students, but can my senior students or even middle school students create a program? And we can see here that it does it straight away, but there's not really much seen there. We could look at the program, which I'm not going to do for this one, but I then there's created another one here, which does the same sort of thing, but allows you to choose your starting number. So I will follow that same question. It allows you to choose the adding number and the multiplying number. So you can see there's greater depth, and this is, again, a nice piece of homework you can set the students. Using TI Connect, they can save it and then email it to me, which I've done in the past. And we can see that the first answer they get is 9. That's correct. 5 take away 2 multiplied by 3 is 9. Take away 2 again is 7 times by 3 is 21. That's correct. And there we go, 57, and then it's done. So the little program for that, just so you get an idea, because I think that sometimes that's what's so nice about the 10 minutes of code is it leads you through it to give you ideas of other things that you can do and how you can apply it to other areas of maths. And that's what I've found with my students, is that they go, can I create a program for this? And off they go, and they're so much keener to want to do more. So here you go, starting number, again, inputs, okay. So the speech marks are giving text. Again, we've now got a label going on here. So what the label does is it basically puts a marker on the program, and it runs this middle section of the program. There's the pause like Brian talked about, and you'd have seen the white circle spinning around. And if it doesn't make these conditions, it goes back up to 1 again. All right, until it gives the final answer. And that's what's going on with that program. Now, there was one more that we were going to show, Brian, wasn't there? And that was a subroutine. That's right. So a subroutine is where we have one program inside another. So you can see here that I've got a program called Window, a very simple program. What it allows me to do is to set the size of my window. Say again?
I was saying it worked for Bill Gates. You could make a fortune with this,
well,
mate.
There you go. Well, imagine if I had that name. If only somebody hasn't taken it already. So I can set my window up. Let's go -3 to 30 with a 3. Now, obviously, students know that they can, and that's a graph I had from earlier, but we can see that the axis now actually replicates what I asked. Now, students know that they can do that in here, but I've created this little program that does the same thing. Again, it doesn't push all students' buttons, but there will be some that they'll all get into it with the 10 minutes of code, but some that then will take it on to the next steps. I'll just show you that one very quickly. So here we are. Here's all the prompts for that, and there we've got display graph, which is the input-output. These are all found in var window. So I'm just going to quit that one because the one I created, and this will be me to finish, Rodney, is, and I go to edit straight up, is called graphing. And this is just graphing, again, a quadratic. So it asks them to display in the form y equals, and then it asks for the prompts for the coefficients of x squared, x, and the constant. And then it will dump that equation into y1. It then runs the program window, and then it returns.
Yeah, that's lovely.
So I'll just show that. So let's clear, oops, yeah, let's clear that. So at the moment, we can go zoom standard. At the moment, nothing's there. So let's run this program very quickly to finish off. We're doing graphing number 4. So the program, right, what is A? Well, let's just go something very simple. I think it was the one we did earlier. 5, 6, what windows do I want? Okay, well, it's going to cross at minus 2 and 3, so let's go minus 5, enter 5, going up by 2. I want my Y min, well, let's go minus 5 up to 20 with an X, with the Y dashes on the scale as 5. And there we go. It's graphing it, and it's dumped it into Y equals. That's the graph. And obviously those constants, the calculator is holding in its head because they're now stored. Those constants are actually there. To prove it to you, there's my A value that I typed in. They'll hold those there until they get wiped over by something else. So it doesn't matter that they're there, but they're being stored. They're a really nice idea of how students can use it. And on that note, Rodney, I am finished. Thank you very much.
You've done well after that brief interruption regarding your internet there. So I totally agree with you. And yes, those things happen with technology. That's wonderful. Sometimes it mucks up. But at the moment, as you see on my screen, I've got the Texas Instruments Australia website. So most people found the webinar section. So if you click into here, you'll see that we have the upcoming webinars, as you see, with the one tonight with Brian and John. And tomorrow night, the same crew is back again with the TI-nspire. And then the future webinars. And tomorrow or the day after, you'll see the webinar and its associated resources, the files and PowerPoints, etc. The gentlemen have used. They'll be there. So you'll see last week's webinars. So Bojana and Pam have actually got the recorded webinar. You can download and play it there, or you can actually download all those documents. So there's many, many webinars. Sorry, I pushed the wrong button. And you can see on the side of the screen it goes on and on. There's so many there. If you think, oh, there's a great webinar a few months ago, have a look for it. You'll find it there. And also, regarding the webinar, I won't go into the PowerPoint, conscious of the time. You'll see that the Texas Instruments loves feedback, as with Brian and John. So if you'd like to comment how well they did through the night, it'd be much appreciated. And then you'll get your email with the link to produce your certificates. And then don't forget, as people will know, the YouTube channel. You can actually look at all the resources there as well. And if you want to learn about LEC days, as they're called, contact Texas Instruments and hop on their email list and subscribe to newsletters. So on that note, thank you everybody for viewing, and we look forward to your participation in future webinars. Good night, Brian.
Good night.
And good night, John.
Thank you, Rodney. Thank you all. Good night.
And we'll see you another time. Bye for now.
Cheers.